we are going to talk about Ostwald's dilution law. So, where does it apply? It applies on weak electrolytes, that is, on weak acids and weak bases. We can apply Ostwald's dilution law. Let us see how does it apply. For example, I'll take a weak acid, let's say acetic acid. So you have CH3COH, it ionizes to give CH3CO minus and H plus. If initially number of moles is initial moles taken equals to 1 mole of carboxylic acid, so initially there will be nothing formed out here, and equilibrium moles, if degree of dissociation is alpha, so number of moles at equilibrium will be, if alpha is degree of dissociation, so moles will left will be 1 minus alpha, and what is formed, alpha and alpha. So equilibrium concentration will become, if we take volume of the container in which this reaction is happening is V liters, volume of the container equals to V liters. So equilibrium concentration will be moles at equilibrium upon volume of the container. So moles at equilibrium is 1 minus alpha. So volume of the container is V. So equilibrium concentration is moles upon volume. Similarly, moles upon volume for acetate is alpha by V, and for H plus is alpha by V. So if we apply this equilibrium constant formula, so degree of dissociation is taken as alpha and dissociation constant is written as Ka. So how we will write that as acetate ion concentration into H plus concentration upon acetic acid concentration, right? So if I put values which we have got here, what you get is 1 minus alpha by V, and 1 minus alpha by V is alpha by V, alpha by V into alpha by V upon 1 minus alpha upon V. That is what the expression we get. What you will see here is that you can cancel out VV, right? And 1 minus alpha could be taken as alpha, because alpha is very very small. 1 minus alpha is very very less than 1. So 1 minus alpha will become nearly equals to 1. Alright. So if I take it to the next page, I'll just clean it up. So what the expression you get at the end of this derivation is C alpha square, because we have ignored this value 1 minus alpha is very very small. So 1 minus alpha we have taken as 1. So if you get this expression from here, you can calculate alpha is equals to root of K by C. So this is the expression. You can use it for calculation of dissociation constant, and alpha is degree of dissociation. That is what has been given out here, that you can calculate degree of dissociation using Ostwald dilution law. Alpha is equals to root of Ka by C for a acid and root of Kb by C for a base. Alright. So Ostwald dilution, what does it tell us about? So alpha, the formula was Ka by C. What does this mean? C is concentration. So alpha is inversely proportional to concentration. Lesser the concentration, more will be ionization, right? So concentration is basically, concentration equals to 1 upon dilution. So if alpha is inversely proportional to concentration, we can say alpha is directly proportional to dilution, right? That is what Ostwald dilution law is, that higher the dilution, higher will be ionization of weak electrolyte. Weak acid or weak bases will be highly ionized at lower concentration or higher dilution. More the dilution, you keep adding water, and the ionization of weak acid, weak base keeps increasing. That is what Ostwald dilution law explained to us. Next, what we are going to talk about is ionic product of water. Water is a very poor electrolyte. So it does not give much ions to us, but up to a certain extent we can get ionization at 25 degrees Celsius. If you watch out, if you see a constant called Kw, this is known as ionic product of water, ionic product of water, right? And the value of this at 25 degrees Celsius, Kw at 25 degrees Celsius is 10 to the power minus 14, 10 to the power minus 14. So that this is equals to H plus concentration into OH minus concentration at 25 degrees Celsius, that is room temperature. So 10 to the power minus 14 is H plus and OH minus concentration product. So each H plus concentration is 10 to the power minus 7 and OH minus concentration equals to 10 to the power minus 7 molar. This is molarity, right? So concentration of both is equal for a neutral solution. Now if you have a acidic solution, acidic solution, acidic solution will have greater H plus concentration than OH minus concentration, right? And basic solution will have greater OH minus concentration. But interesting thing is, whether you take a acidic solution, basic solution and neutral solution will have both of these equal. H plus concentration will be equal to OH minus concentration. But in all these, ionic product of water Kw will be 10 to the power minus 14. Whether it is acidic solution or basic solution, all will have ionic product equals to Kw equals to 10 to the power minus 14. That means product of H plus concentration and OH minus concentration does not change, whether be it acidic solution, basic solution or neutral solution. So ionic product is a constant, it is a dissociation constant or equilibrium constant, you can call it. It only depends on temperature. It does not change whether acidic, basic or neutral solution, right? So this is an interesting point you should keep in mind. Now we have a pH scale. Who gave this scale? The name of the scientist was Sorensen. Sorensen gave a pH scale. So what is pH? pH is pH is equals to negative logarithm of H plus ion concentration. So what do you think? I can write it like this: log of 1 upon H plus concentration, right? So what do you think? pH and H plus concentration, are they directly related? I think you will say no. They are inversely related. So higher the H plus concentration, lower will be pH. So that means H plus concentration tells you about acidic character. So more the acidic character, less will be pH, right? So he gave a scale at 25 degrees Celsius. pH scale starts from 0 to 14. So this pH scale starts from 0 to 14, and this middle point 7 is the neutral pH. So if you say neutral solution is there, pH is 7. If we go from 7 to 0, acidic character increases. Acidic character increases if you go from 7 to 0. If we go 7 to 14, basic character increases. Basic character increases from 7 to 14. So neutral pH is 7, less than 7 is acidic, more than 7 is basic. So from here, I hope you understand that higher the pH, more will be basic character. Lesser the pH, more will be acidic character. That's it for now.